Okay, let's talk more on statistics. As we already know, statistics is the arts and science of learning from data. Statistics basically, we may say it has two branches. One is descriptive statistics, another is inferential statistics. Descriptive statistics is to describe the data by using graphs or some summary numbers. Inferential statistics means using those numbers to make a prediction or inference about something. Okay, in descriptive we do calculation, we calculate numbers in descriptive statistics, and we use those numbers to make some kind of prediction in inferential statistics. And there are few numbers, they are highly important if we want to understand the data or if we want to do data analysis. The one set of the numbers is called measure of central tendency. Measure of central tendency means we are trying to know the center, the core of the data, or in ordinary language we call it average. So, measure of central tendency refers to average. Well, by average we might mean several things. One of the average is called the mean. So, let us look at the example. Mean is one of the center of the data, and let us look at this example. Find the mean or the mean of the heights of the 7 children. In order to find mean, we simply add the values and divide by how many of them are there. So, in order to calculate the mean, what we do is we add this values 123 plus 123 plus 124 plus 125 plus 129 plus 129. These are the 7 values we have in this particular data. 1, 2, 3, 4, 5, 6. I am missing 1, 123, 123, 124, 1, 2, 3, 4, 5, 6, 7. I am missing one more, 129. Okay. So, we add the observation and divide by how many of them are there. In this case, there are 7 of them. So, the mean is the sum in the numerator. We have to add the numbers in the numerator and divide by 7. So, let us use the calculator to add these numbers and divide by 7 and see how much we will get. Okay, it turns out to be 882 divided by 7. This is 882 divided by 7. So, that is 126. So, we can say on average the 7 children are 126 centimeter tall. So, that 126 centimeter is an average. So, that is representing the center, the core of our data. Another measure of central tendency, another center, another average of the data is called the median. Median basically divides the data into 2 equal halves. We order the data from smallest to lowest, and median will divide the data into 2 equal halves. So, if we want to find median for this example, let us say 1, 2, 3, 4, 5, 6, 7. If we want to divide this data into 2 equal half, 3 observations will fall on the upper half, 3 observation will fall on the lower half, and this 125 is dividing the data into 2 equal half. So, that 125 is called the median. So, median in this case is 125. Okay. The another measure of center is called the mode. and mode is simply the observation that repeats the most. Mode is the observation that repeats the most, that comes most frequently. So, if we look at our data, our example here, 123, there are two 123, 123 is repeating twice, 124 is only once, 125 is only once, 129 three of them. So, 129 is repeating 3 times. So, for this example, the mode equals 129. Mode is the observation that repeats the most. Well, there is one more plot, there is one more graph, which is, this graph is very important in statistics. It is called box plot. In order to construct a box plot, we have to find the median of the data. We will, in the box plot, we will have a box. The lower end of the box represents the lower quartile. The upper end of the box represents the upper quartile, and there will be a whisker going to the left from the lower end of the box, and there will be another whisker going to the right from the upper end of the box. This is the lowest point, lowest data value. This is the highest, the maximum of the maximum in our data value. This is the minimum in data value. This is the lower quartile. This is the upper quartile, and the median is in between the lower quartile and upper quartile in the box. So, basically, in order to construct a big box plot, we need to know the minimum of the data, we need to know the maximum of the data, we need to know the lower quartile of the data, we need to know the upper quartile of the data, and we need to know the median of the data. We already know how to calculate the median. So, let us work on how to find the quartile. Minimum and maximum are easy. Minimum is the lowest, maximum is the highest. So, the only thing we need to talk in order to understand the box plot, or in order to construct a box plot, is the upper and lower quartile. So, let us look at this example. Suppose this data is given to us and we want to calculate the quartiles. Okay. Suppose we want to calculate the quartiles. In order to calculate the quartiles, the first thing we need to do is order the data from the lowest to the highest. So, the lowest number is 1 in our data and the highest number is 26, and everything is ordered. In order to calculate the quartile, the first thing is to find the median. Let us count how many observations do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, let me add one more to make it 15. Let us add one more observation, 21, to make it 15. So, things will be easier. So, there are 15 observations. So, if we take the 8th observation, 1, 2, 3, 4, 5, 6, 7, 8, if we take this, there will be 7 observations on the lower half, there will be 7 observations on the upper half. So, the median for this data is 14. Now, the lower quartile is nothing more than the lower quartile is nothing more than the median of the lower half. This is our lower half. If we find the median of this lower half, we have the lower quartile. This is our upper half. If we find the median of the upper half, we have the upper quartile. So, basically, in order to calculate the lower quartile, we have to calculate the median of this lower half, median of everything below the median. So, let us see, we have 1, 2, 3, 4, 5, 6, 7 observation in the lower half. If we take the third observation, there will be 3 observation below it, 3 observation above it. We are just looking all the way up to lower half. Okay, we are just focused on the lower half. So, this is the first quartile, sometimes written as Q1. If we do the same thing, this is our upper half. There are 7 observations. Let us put 3 of them below this number and 3 of them above this number. So, this is our third quartile, Q3 or upper quartile, lower quartile and upper quartile. So, if we had to construct box plot for this particular data, our box plot will look like this. Well, we are going from 1 to 29. So, this is the line. Let us say here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on, so on, so on, so on, so on, so on. This is, let us say, somewhere 29. This is the minimum, and this is the maximum here. We will have a box extending from lower quartile to upper quartile. So, this is 12. So, 21 will be somewhere here. So, 21. So, this is the box, this is the lower end of the box, this is the upper end of the box, and the lower edge of the box will be connecting to the smallest and the upper edge will be connecting to the largest. Now, the median is 14. So, this is 12, this is 13, this is 14. So, this is median. So, this is Q1, this is Q3, this is median, this is the maximum, this is the minimum, and here is the maximum. This is what we call a box plot. And these quartiles are used to calculate something, one important quantity in statistics, and that important quantity is called interquartile range. That interquartile range tells us how variable or how compact, how clustered the data are. So, the interquartile range is nothing more than Q3 minus Q1. The difference of the third quartile and the first quartile is what we call interquartile range. So, in this example, interquartile range will be the upper quartile is 21, the lower quartile is 12. So, 21 minus 12, that is 9, is the interquartile range. If we have another data whose interquartile range is 8, then we could say 8 or 7, let us say, then we could say the another data is less variable in compared to this data. The larger the interquartile range, the more the variable the data is, the more spread the data is. The smaller the interquartile range, the variability of that data is small. That means they will be clustered together. Okay. So, that is interquartile range. Now, another thing we want to talk is measure of variability. One measure of variability we already talked, that interquartile range represents the variability. There are other various numbers that represent how clustered the data are or how spread the data are. The numbers that represents the clusteredness or the spreadness of the data is called, they are called measure of variability. One measure of variability, as I already mentioned, is the interquartile range. There are other nicer, more useful measure of variability. We are going to look at them. One of the simplest kind of measure of variability is called the range. Range is nothing more than the largest minus smallest. In any data set, the difference of the smallest observation and the largest observation is called the range. So, the lower the range, the lesser the data is variable, the variation is less. Now, let us look at this example. We have a data set A and we have a data set B. There are two different data. We want to know which of the two are more variable or less variable. One of the things we can do to identify the variability, less or more, is to calculate the range. So, for set A, for data set A, the range equals, if we want to calculate the range equals, the largest is 5, the smallest is 1, so 5 minus 1, that is 4. And for the data set B, range is, again if we do the same thing, the largest is 5, smallest is 1, so it is again 5 minus 1, that is 4. Just looking at range, both of them are 4, we might say the two data set have the same variability, same spread. However, that is not true. So range is a measure of spread, but it is not a good measure. It does not capture the real variation. Another number that can be used to capture the variation of the data is called mean deviation. In order to calculate the mean deviation, first of all we calculate the mean of the data. So let us say this is for data set A and this is for data set B. So for the data set A is 1, 2, 3, 3, 3, 3, 3, 3, 4, 5. If we find the mean of this, data set, mean is 3. Mean is simply adding them and dividing by how many of them are here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them there. So if you add this number, divide by 10, we get 3. So 3 is the mean. In order to calculate the mean deviation, in order to calculate this quantity, we subtract the mean, which is 3 in this case, from each of the observation. So we do 1 minus 3. 1 minus 3 is negative 2. 2 minus 3, negative 1. 3 minus 3, 0. So this is the number minus the mean. 3 minus 3, 0. 3 minus 3, 0. 3 minus 3, 0. 3 minus 3, 0. 4 minus 3 is 1. 5 minus 2 is 3. Then after calculating the difference of mean from each observation, we add them up. So, well, we have to calculate the distance. Once we have this difference, we take the absolute value of this. We ignore the sign, we just take the absolute value. So we take 2, 1, 0, ignore the sign, 0, I'll take the positive part of the number. So 1, 2. Now in order to calculate the mean deviation, we add this number. Sum of this, we add them. 2 plus 1, 3 plus 0, 0, 0, 0, 4 and 2. 2 plus 1, 3, 2 plus 1, 3, 3 plus 3, 6. So the sum will be 6. And therefore, the mean deviation will be, so in this case, the mean deviation will be this will be equal to the sum 6 divided by 10 of them. So we divide by how many of them are there. So this sum of this deviation is 6 divided by 10. So the mean deviation will be 0.6. Now let us do the same calculation for data set B. Data set B is 1, 1, 1, 1, 2, 4, 5, 5, 5, 5. If we calculate the mean of this will be equal to 3 as well. Add them up, divide by 10, you will get 3. Now we subtract the mean from each of them. So 1 minus 3 is negative 2, 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 2 minus 3 is negative 1, 4 minus 3 is 1, 5 minus 3 is 2, 5 minus 3 is 2, 5 minus 2 is 3, and we have all these differences. Now we just take the positive of them, we ignore the sign minus. So this will be 2, 2, 2, 2, 1, 1, 2, 2, 2, 2. And we add them. If we add this, if we add all of this, add to get the sum equals 2 plus 2 4, plus 2 is 6, plus 2 8, plus 1 9, plus 1 10, 12, 14, 16, 18 and divided by, there are 10 of them, 10. So, we will get 1.8. This is the mean deviation. So, let me write MD for it. So, the mean deviation is 1.8. So, if we look at the number mean deviation for first data set A, mean deviation is 0.6. For the data set B, the mean deviation is 1.8. 1.8 is of course bigger than 0.6. So, we can say the second data is more variable than the first. Okay. Let us look at another measure of variation. The another measure of variation, they are called standard deviation and variance. You know, they have a close connection. Standard deviation, or I would say this way, variance, this is square of standard deviation. Variance is nothing more than square of standard deviation, or you may say standard deviation is square root of the variance. Variance is the square of standard deviation is the square of variance. Okay. So, how do we calculate them? In order to calculate the variance or the standard deviation, we will follow the same table. So, let us look at this table for a second, and we will be following the same table. So, in order to calculate the variance or the standard deviation, this is what we do. We make a table where the first column is the observation, the second column as before is the observation minus the mean. Mean is written as x bar, that x bar represents the mean, and then we do x minus x bar square, we square them. This is the table we will create in order to calculate the standard deviation or the variance. So, I will be using this number, let us say 1, 2, bunch of 3 and 4, 5. So, I will be using the previous table, the previous data to calculate the standard deviation. So, it says 1, 2, 3, 3, 3, 3, 3, 3, there are 10 of them. So, 1, 2, 3, 4, 5, 6, 7, 8 and 4, 5. This is our first data set. And as done earlier, we know the mean x bar for this data is 3. So, here as before 1 minus 3 negative 2, 2 minus 3 negative 1, 3 minus 3 0, 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 1, 2, 3, 4, 5, 6, 7, 1 more 0, 4 minus 3 is 1, 5 minus 3 is 2. So, when calculating mean deviation, we just took the positive of every number, simply we ignore the sign. In order to calculate the variance, we square them. Negative 2 square is 4, negative 2 times negative 2 is 4, negative 1 square is 1, 0 square is 0, 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 1 square is 1 and 2 square is 4. Now, we add them up, add these up, add them. If we add them, the sum will be equal to 4 plus 1 5 plus 1 6 plus 1 10. So, the sum is 10 and the variance is nothing more than this sum, which is 10 divided by the number of observation. The number of observation in this case is 10 the number of, there are 10 observation. So 10 divided by 10, that's 1. So the variance is 1. And as already explained, the standard deviation is nothing more than square root of 1, which is simply 1. Standard deviation is the square root of the variance. Now, if we do the same calculation for this data set B, for this data, do the same calculation for data set B, this is for set A. If we do the same calculation for data set B, if we do the same thing for data B, we will get variance and standard deviation. Let me write SD for the standard deviation, SD for standard deviation. We will get the variance to be 3.4 and standard deviation to be 1.8. Variance is 3.4 and the standard deviation is 1.8. Now you see, again, the larger the variance, that means more the variability, the larger the standard deviation, the more the variation or the variability. So comparing the standard, the variance of this data set is 1, the variance of data set B is 3.4. So we can say the second data set is more variable in compared to the first data set. Here is a nice result regarding data distribution. It says at least 70% of measurement in any set of the data will lie within 2 standard deviation of the mean. So this is what this is saying. Suppose this is the mean of the data, x bar is the mean of the data. Go 1 standard deviation, x bar plus standard deviation 1, again go x bar plus 2 standard deviation, 2 times standard deviation, and on the left subtract 1 standard deviation and again subtract 1 more standard deviation. So x minus 2 standard deviation. From this point to this point, for any data from this point to this point, there has to be at least 75% of the values. So outside of these two, there will be only 25% of the values at most. At least 75% means there could be 80%, there could be 90%, there could be 99% in between this value and this value. That's what this is talking about. Okay. Let's talk about sampling, prediction and simulation. Well, in statistics, one of the things we should consider is we have two similar looking words and we often get confused. We have sample and we have population. Population means everything under the topic of discussion, and a sample is a small subset of population. Sample is small subset of population. Population is everything. Random sampling. In order to get a sample, we apply various methods. In order to choose 20 people out of 1 million people, the set of 1 million people is the population. The set of 20 people we select out of that 1 million people is what we call sample. In order to identify the 20 people we want to take in our sample, there are various different sampling techniques. One of the very powerful and very frequently used and a very good sampling technique is called random sampling. Random sampling is the sampling method where each individual in the population has equal probability of coming into the sample. Random sampling means you don't want to exclude anybody from coming. You want to develop a procedure so that everybody has the equal chance of coming into the sample. That kind of sampling techniques is called random sampling, and random sampling is very difficult to achieve. If you think of sampling 1,000 people out of United States, it is very difficult to develop, to come up with a method so that every individual have the equal chance of being into the sample. It's very difficult. It's very difficult to achieve that. However, when we do statistics, we try to make sampling as random as possible, and in order to make the sample as random as possible, we take help of something called random numbers. For example, in order to get, let's say 1, 2, 3, 4, 5, 15, 30, 45, 60. Let's say I want to collect a sample of 60, 15, 30, 60 individual from the United States, and I want to get the random sample. One of the things I might want to do is use the random digits. So this is a randomly generated digit, and I might contact people whose well, these are 5-digit random digits, so probably I want to use the last 5 digit of their social security number, or the last I want to call people whose last 5 digit of their telephone is this. That's how I can collect a semi-random sample of 60 people. So in order to do random sampling, people use random numbers. These days, the computer programs can generate random numbers, and another way to get the random numbers is to follow some random numbers table. They have been generated and they are for us. This is an example of random number table. If you look at your book, you will find other random number tables as well. And computers and calculators can generate random numbers also. We talked about data distribution before, and we said that 75% of the data should be in between within the 2 standard deviation of the mean, at least. Now we want to talk about the shape of the data distribution. By shape we mean the histogram. We know about histogram. The histogram of a data distribution might look like this, might look like this, or might look like this. If you look at the graph in the middle, you see this is more symmetric. You can see the lower half looks the same as the upper half. If we have a distribution, if we have a graph which looks like this, the lower half is the same as the upper half and kind of bell shaped, this is called symmetric distribution. It is symmetric. Now if we find a graph where the lower side of the graph is longer than the upper side, this is called left skewed or the negatively skewed distribution. And if the histogram looks like this, where the right side is a lot longer than the left side, the right tail is a lot longer than the left tail, this is called right skewed or positively skewed. So we can have 3 different kind of shape: symmetric, right skewed, or left skewed. The symmetric distribution which looks like this, look at the shape, more or less looks like a bell. a bell-shaped symmetric distribution. In the language of statistics, they are called normal distribution. This is what the shape of the normal distribution looks like. And for normal distribution, we have a rule how the data is distributed, and the rule says 68% of the data should lie in between within 1 standard deviation of the mean. So, go 1 standard deviation away to the right from the mean, go 1 standard deviation away to the left of the mean. In that region from here to here, there has to be 68% of the observation if the distribution is normal distribution. Normal distributions are symmetric bell-shaped distribution. Similarly, it says 95% should lie in between within the 2 standard deviation of the mean, and 99.7% should lie within 3 standard deviation of the mean. That means from mean go 3 standard deviation to the right, 3 standard deviation away to the right, go 3 standard deviation below the right, we will be capturing 99.7% of the data. That means if we go 3 standard deviation below the mean, 3 standard deviation above the mean, that means we will be excluding only 0.3% of the data. That means if we go 3 standard deviation below the mean, 3 standard deviation above the mean, we are capturing almost everything in the distribution, almost everything. That 0.3 is very small exclusion. Well, another statistical numbers, quantities of interest are called percentiles. Percentiles divides the data into 100 parts. So, let us say this is our smallest observation, and let us say this is our largest observation, and there are bunch of observations here. If we divide this observation into 100 parts, equal parts, then number of observation, let us say this is the observation, let us say there are 13 not a good number, 12% of the observations are below it. If 12% of the observation are below this value, then this value is called the 12th percentile. Percentile 12th percentile means 12% of the values are below that observation. 80th percentile means 80% of the observations are below it. So, this is the minimum, this is the maximum, and if we think of the 80th percentile, that has to be somewhere around here. If this is the 80th percentile, 80% will be below it. This is called 80th percentile. That is the concept of percentile. We divide the data into 100 parts, and for a particular observation, the percentage of the observation below it is its percentile rank. Okay. Another statistical quantity of our interest is G-scores. G-scores and percentile both represents the position of a particular observation in the data set. G-score is calculated using this formula. For any observation, G-score is the observation x minus the mean x bar and divide by the standard deviation. If we divide an observation minus the mean by standard deviation, we get the G-score. Let us look at one example based on the previously worked problem. So, okay, 1.8. So, what we know for this data set B is, what we know is x bar for this is 3 and the standard deviation is 1.8. if I want to calculate G score for 1, let's calculate G score for 1, 4 and 5 and let's see what happens. G score for 1, 4 and 5. For that particular data set, for data set A, for data set A, I am thinking of data set A, we know x bar is 3 and standard deviation is 1.8. Now G score for 1, every individual observation will have its G score. 1 is an observation in the data set, so the G score for that observation 1 will be 1, the observation, minus the mean divided by 1.8. So it will be negative 2 divided by 1.8, and if we divide negative 2 by 1.8, 1.8 divided by 2, that turns out to be 0.9. So the G score for that will be negative 0.9. And similarly, G score for 4 or 5, let's say 5 will give the same thing, so let me say 4. G score for 4 will be 4 minus 3, the observation is 4, the value is 4, subtract the mean, divide by 1.8, so this will be 1 divided by 1.8, so G score will be 1 divided by 1.8, 1 divided by 1.8, that's 0.5555, so almost 0.6. So this is almost 0.6. You notice the observation, they are close to mean will have a small G score, the observations they are far away from the mean will have a bigger G score. Okay. Simulation. Simulation is a technique in statistics and it refers to conducting some experiment repeatedly. For example, let us say I want to know if I toss a coin, I want to know what will be the probability of getting a head. Suppose my question is, well, let me put another question in a different way. Suppose I am tossing a coin, I want to know if I toss a coin 5 times, how many heads will come. Okay, what on average how many heads will come if I toss a coin 5 times. So if that's my question, I can really do the experiment. Suppose I toss the coin 5 times and let's say I get a head. This is one trial done. And let's say I toss, this is a 5-time toss, and I'll toss the coin 5 times again, and let's say I get head, tail, head. Next experiment of tossing the coin 5 times. Let's say I toss the coin 5 times again and I get head, tail. So this I am repeating the experiment of tossing the coin 5 times. That is an example of simulation. And if I do in order for us to make this a simulation, I have to repeat this process several times. And if I repeat this process several times, I can say on average how many tails will be there. For example, for this particular experiment, there are, if I think of tails, there are 0 tails. For this particular experiment, there are 3 tails. For this particular experiment, there are 3 tails. If I simulate this process a lot of times, so many experiment will give me 1 tail, so many experiment will give me 2 tails, so many experiment will give me 3 tails, and if I average them out, 4 tails and 5 tails as well, if I average them out, I can say on average, if I toss a coin 5 times, this many times tails should appear. So, the concept of simulation is to repeat experiment repeatedly, do experiment several times and see what happens. Let me know if you have any question. Thank you for watching.